Hello.
Hello, Logan.
Uh, I think it's just me today.
It is just you
Or
today. That's correct.
yeah,
Ryan said he might join for 5 minutes.
yeah, yeah.
Also,
I yeah. I doubt he'll get the time though. Yeah.
yeah, I agree. Oh, how you doing? You said these
Kind
were
of
two
tired.
very important weeks.
Yeah, yeah.
Elaborate, please.
Uh, I just turned in like all of my scholarship stuff and stuff like that, and
Oh,
like we just had like our final arts festival like
uh-huh.
last week, which is what I've been practicing for. But
I
now I'm
see.
done.
Wow.
Oh, but I did get a scholarship back
Oh,
for Wash U. Yeah.
oh, St. Louis.
Yeah, yeah.
Great. Congratulations.
Thanks, thanks.
Good. I see. Yeah, that's important stuff. Absolutely. Uh, yeah. That decides which colleges you can go to. You need to get enough money.
Yeah. I mean, I'm probably going there. Yeah, like that's it's the best for us. That's
Uh-huh.
all I have to say.
Good. So you've yeah, you have a huge load. I have to say, if I were your counselor, I would
Yeah.
not have let you take all that. That's who I think is at fault. That's crazy. We never let it in my very elite private school where I taught. We never let people take a load like.
Yeah.
Okay, well, good lesson for
Yeah.
the
Yeah.
future. Don't overdo it.
Yeah.
Okay. So yeah, so I am here to help you. I have one question because you sent your homework, and two of the files, and I get this sometimes, but sometimes they're duplicates, but this time they weren't. Let me uh, let me see which ones. I'm just getting them up. Ah, yeah. Okay. All right. So I got the 3D symmetry figures. That's fine. I got inversion, and I got your inversion GeoGebra sketch. But
Yeah.
the two other files, which are the homework assignment and the smooth moves, um, they come to me with this tilde $ R in the front, or on one of them, and tilde $V on the other. And when I try to open them, at least by double clicking, I guess I could try to open them from Word. Let me see if that works. Then it just says it's an MS DOS text file, and then when I open it, nothing good happens. So
Yeah.
it could be because you always zip you always compress your files, right, before you send them.
Yeah. Yeah.
And I'm not sure that that's necessary, I guess. Um,
Should I just send like all the individual ones,
I think
maybe?
so. I think so.
Okay.
Let me try to open this one from Word. Yeah. Did I get this message that says convert file from MS-DOS text? Yes.
Yeah.
So those two files, just send them individually, and I think in the future you don't need to compress.
Yeah.
Uh, the size isn't a problem, and I think that might cause some issues. So those two files, okay? Did you get which ones I'm talking about?
Yeah, I think the other one was just the assignment. I actually wanted to talk about like
No,
um
I'm
one
ready
of
to.
them because I didn't really understand it. I don't know.
Okay. Um, how about if you share your screen? So I'll just close this, and yeah. So I'm in Adobe. Oh, first I have to. Wait a second. First I have to. Oh no, that's only if I want to share my screen. Yeah. So I'm going to go into. Let's see. I have to do this. Yeah. Okay. So I'm now on the Adobe Connect Friday screen, and you can share your. Let's see. Wait a minute. I have to. Yeah, you have to get in there first, and then I'll make you a presenter.
Yeah.
There you are. All right. Yeah. Okay. Now you are a presenter. So why don't you share your screen and get up any files? Oh yeah, in order for the
Yeah.
I have to share. There you are.
Oh, that was weird. Yeah.
Yeah, it just glitched. Um, all right, so I'm going to try this again. This is just for recording purposes. Actually, well, I'll try it one more time, and if it gives a problem, now it's fine. Okay, so I am ready to have you share your screen on Adobe Connect Friday, and then you can show me whatever file you want have questions with, and we'll talk about it.
I just wanted it said to do number 7 on the complex numbers thing.
Right.
I read through it, like I didn't know what the problems were.
Okay. So let's get that. Yeah, share your screen and get that file up, and let's see, and we'll go from there. Okay.
It's one of these. Yeah. Like
Oh, yeah. Right. I'm going to put this on full screen. Not going to work.
do I just zoom in here or?
Yeah, yeah. There you go. There you go. That's good.
Yeah, I read through it, like I understood it. It's just
Mhm.
what was I supposed to do?
Wasn't there red? Oh, there's not red text in your version. Yeah. Was that the plus? One of them had a plus.
Oh, it's one of these. I can just re-download it.
Yeah, it's the latest one that has I'm not sure, where it is, but I can.
Yeah, it's one of these. Yeah, this one.
Yeah, that one. I was putting it in every one, but then I found that seemed to be confusing because I wanted you guys to continue, on the one that you had worked on. Yeah, this has some red type, yeah, which is what I want. Now, if you go to 7, yeah, see?
Okay.
Yeah.
I see.
So the red type is what I wanted you to do.
Yeah. Okay. A real number equals I to the I. Wait, so like...
Yeah. So you take e to the I pi over 2 equals I. You see that on 2 lines up?
Yeah.
And you raise both sides to the I power. And use laws of exponent.
Oh, so it would it be 1 over root 4 negative 1? Or,
where do you get the root 4 from?
because I is already it's the square root of negative 1, right? I mean,
yeah.
And then as an exponent, that'd be like negative 1/2.
Yes. Yes.
And so you'd put I on the bottom, so 1 over I, and then you'd find the square root of the bottom. Oh, but that's not.
You're making it hard.
Yeah.
If you just raise both sides to the I power, and don't worry about square root of -1 or anything like that, what happens? What happens to the exponents when you raise e to a power to another power? What do you do to the exponents?
I'm confused. Yeah.
Okay. If you have 2 cubed, yeah. If you have 2 cubed and you raise it, well, I want to make the numbers so you don't deal with the numbers. Let's say 11 cubed, right? 11 cubed, and you square it. What do you have?
11/6. 11 to the 6.
So what did you do to the exponents?
You multiplied them.
Yeah, okay. So same thing here. So you have the exponent of e is I pi over 2 right now. Okay?
Yeah.
And you're raising it to the I power, so you multiply the I pi over 2 by I. And what happens when you multiply I times pi over 2 times I?
I'm sorry, you lost me at the very last part. I'm sorry.
Okay. The current exponent is I pi over 2.
Yeah.
And you're going to multiply that by I.
Yeah.
So what is I pi over 2 times I?
Negative pi over 2?
Yes. So the new exponent is minus pi over 2.
Yeah.
Okay. So e to the minus pi over 2 is equal to I to the I.
Oh. Oh,
And
that
e to
was...
the minus pi over 2 is a real number.
Yeah. That's a lot simpler than what I thought.
Okay. So it's
Okay.
e to the minus pi over 2. And you can check that by using Wolfram alpha, and just compute e to the minus pi over 2, and then ask it what I to the I is, and see if you get the same answer.
Yeah.
Okay? Does that make sense?
Yeah.
Okay. Yeah, things sometimes turn out to be easier than you think, which is nice.
Yeah.
Okay, then the next part says Euler's identity is useful because the laws of exponents are much simpler and easier to use than trigonometric identities. Okay. As an example, they show the relationship between circular and hyperbolic functions. So, cosine x, first of all, do you see why cosine x equals e to the ix plus e to the minus ix over 2? For that, you have to go up a little bit in the file. Yeah, you see this important identity, e to the plus or minus ix? Yeah, that one. E to the plus or minus ix equals cosine x plus I sine x?
Yeah.
So that's two identities. The main one is the plus one. E to the ix equals cosine x plus I sine x.
Yeah.
Okay. And then e to the minus ix is equal to actually both of them are important. E to the minus ix is cosine x minus I sine x.
Okay.
All right. And then if you use both of those equations, and you add them together, you'll get that identity with cosine x. Because the signs the I sign will be plus in one of them and minus in the other. And that'll go away. All right?
Yeah.
All right. And then do you know anything about hyperbolic functions?
Not really.
Okay. So they're similar to circular functions. Circular functions are, cosine and sine are based on x squared plus y squared equals 1, the unit circle, right? The parameterization of the unit circle is cosine theta, sine theta. That gives a point on the unit circle for angle theta. Well, similarly, the hyperbola is the unit hyperbola, so to speak, is x squared minus y squared equals 1. Very close. And there are hyperbolic functions, cosh it's called, hyperbolic cosine and hyperbolic sine, sinh. And they're a similar parameterization for x squared minus y squared equals 1. And they're very similar. You can see that the only difference is that the I is missing in cosh. So it seems without that identity of e to the ix equals sine x, cosine x plus I sine x, you couldn't see that similarity. See, without complex numbers, they look completely different. Cosine x is one thing which has no e's in it, or what's going on, and then cosh has these e's. Well, e to the x, where did that come from? But with complex numbers, you see that they're really quite similar. So cosine x is equal to cosh of ix, right? Because if you substituted ix instead of x, you would get the same formula for cosh.
Yeah.
All right. And then it says find a similar formula for sine x. For several things. For sine x, which you would get by subtracting the two equations instead of adding them. The two equations being e to the ix equals cosine x plus I sine x, and e to the minus ix equals cosine x minus I sine x. So if you subtract those equations instead of adding them, you get a similar equation for sine x. There's also a similar formula for sinh x, which you can find that's similar to cosh, and it says use the web. You can find that on the web. I think it's the same thing except there's a minus sign, but I'm not positive. You can do that right now if you want. And then you can find a very similar relationship between sine x and sinh ix. Okay, it's really very similar to what we did. There's just sign changes. That's all.
Yeah.
Okay. Does that make sense?
It does. Yeah.
All right. So that takes care of that. What other questions do you have, or what else do you want me to look at?
Oh, maybe the inversions. I felt like my response was really.
Yeah, you weren't sure about it.
Can you look at it? Yeah.
Sure, absolutely. Absolutely. Okay. Yeah, let's look at the beginning. Let's look at number one, and we're going to go over those again next time. Okay. So that was supposed to be circle O. I guess that part of the, a little circle symbol, that font didn't come through. But do you understand the steps of the construction? So given the point P, we're going to find the inversion P prime using the diagram. Can you describe what's being done?
I think so.
Okay, so do that.
You start out with a circle O with some size.
Right. Let's call that the inversion circle. That's the one that we're going to reflect in.
And then you take another point outside of the circle, and you make that the radius of a circle that intersects the triangle, the circle. Wait, the inversion circle at 2 points.
Yeah, but there's something more involved. It's a special circle. There are lots of circles centered at P that intersect the circle at 2 points, but this one is special. What's special about it?
Which points are given? Like A?
Okay. The circle O is given. That's a good point. Yeah. Circle O is given. Okay. So the point O is given, and the radius is given. That's what R is. R is just a point on the circle. So that determines its radius. It's not the intersection point. That's kind of R is not the intersection. Okay. Just a minute. And then you're given P.
Yeah.
That's it. That's what you're getting.
Oh, well, the distance from, actually, can I go for circle A first? Can I try?
No. Because the construction starts with P. You don't know A yet.
Starts with P.
So the question is, how do you determine A? The circle is centered at P, but how do you determine its radius? There are lots of circles that are centered at P that hit circle O in 2 points. But this one is special. And what's special about it?
Well, it hits this.
Yes?
Well, it intersects the center of the circle. I mean.
Yes! That's the
Wait,
point.
that was the answer?
Yes.
Oh. Oh.
Yes.
Oh.
You take PO as the radius. That's right.
Yeah.
So you take PO as the radius and you draw a circle. And that intersects circle O at A.
Yeah.
Now you have A. Now go
on. The distance from A to O or R to A.
Yeah.
Is the radius of circle A.
Yes.
And point P prime is found from the intersection of circle A and segment OP.
Good. You've now described the steps.
Okay, yeah.
All right. So you've described the steps.
So
yeah, you can write that.
Like given
yeah, you can write it.
Circle O. No.
Yeah, you're actually given 2 things. You're given circle O, but you're also given
point P.
Yes.
Using P as the center and segment OP as the radius.
Good.
Maybe circle P. Oh, okay. So point A is one of the intersections of circle P and circle O.
Good.
Form a third circle using A as the center and length O A as the radius. Point P prime. Where's the prime? No.
Yeah, that's good.
Yeah,
that's fine. It's fine. Don't worry.
Intersection of circle A and segment OP.
Good. Perfect. Okay. So that's the first part. Now, before you go on, go back because there was more. Yeah. So explain why. The second part is explain why it works. And that's not so easy. I think for this, the best thing to do is to open that sketch, pre-image outside, that GeoGebra sketch. Yeah, did you download the file?
No, but I remember making one. But I'll download it.
Yeah, you can just download the file. That's the easy way.
Is it under the class files or?
It should be. There it is. Free image outside. You got it right there.
Outside. Can I just drag this in here? Yes, I can. That's cool.
Oh, there it is. Good. Great. All right. Yeah, you're very proficient with software. That's nice. That's a good skill.
Thank you.
Yeah, no, it absolutely is. Okay, so here's our situation, and you can see that as you move P, you should be able to see that as you move P, P prime moves too. Yeah.
Yeah.
Okay. All right, so just put it back in a reasonable, yeah. Now, do you remember the definition of inversion?
No.
Okay, I'll remind you. P prime is a point on segment OP. So that's the first condition. Or if P were inside, then it would be on ray OP, right? I mean, it's on the same line, is the point.
Yeah.
In the same direction from the center. But the distance OP times the distance OP prime is equal to the square of the radius of the circle.
I do remember that, actually.
And the reason it has to be the square is that if P were on the circle, right, then P prime would equal P. It's like being on the line of reflection, right?
Yeah.
And then the product of the distances has to be the radius squared, right?
Yeah.
So the point is that product remains r squared when you move off the circle.
Yeah.
Okay? All right, so that's what we have to prove. We have to prove that OP times OP prime equals r squared. And that's not immediately obvious, right?
Yeah.
Not to me. So we need a strategy. And do you have any thoughts? I guess, yeah. So let me just start with, do you have any thoughts? And then if you don't, then I'll give you some answers.
Okay.
Hello?
Hello.
Hello.
Hey, Ryan.
Hi, how are y'all?
Hi. We're good. So let's say hello.
Yeah. So what are y'all working on?
I'm answering Logan's questions about the inversion, and
Okay.
we're gonna go over this too for Walter again. But before that, I answered questions about the number 7 on the history of complex numbers
Okay.
sheet, which was about e to the ix equals cosine x plus I sine x, that stuff.
Okay.
Okay, that's what I did. So how are you doing? What's going on?
I'm doing pretty well. Right now, I'm in like a little break session, and we're gonna be talking to our admissions counselor here at University of Tulsa.
Uh-huh.
And yeah, we just did a campus tour, and then I went to the study abroad thing.
Oh,
Yeah.
so what do you think so far?
It's really nice. I like it.
Uh-huh.
It's really windy today though, so
Oh,
it's cold.
Oh, cold and windy.
Yep.
Oklahoma is pretty windy, isn't it?
Yeah.
In general, I
so.
think it is. I think they're starting to harness their wind power. That's one of the states that has, in addition to having lots of oil, of course, they also have wind, and that's energy. Well, that's good.
Yeah.
So how long is your break, or are you on break at all?
It's about 10 minutes. It's like in between meetings.
Okay.
Yeah.
All right. So I'll just continue to work with Logan, and you can watch.
Mm-hmm.
And then, well, like I said, we'll go over this again. So we had gone over the construction of point P prime when P is outside, and which is the inversion image. And Logan just wrote out the steps, and that part was fine. And now we're going to try to confirm that P prime really is the image. And in order to do that, we have to confirm that OP times OP prime equals R squared, because that's the definition. So I asked Logan to think about how you get started, see if he has any ideas. And that's where we are. So Logan, do you have any ideas?
I still need to think about it.
Okay.
Yeah, can I think about it for a second?
Sure, absolutely, yes. That's one of the things I learned as a teacher slowly, unfortunately, is that wait time is really important. So I'm waiting.
Could you repeat what we're trying to prove in this one?
We're trying to prove that. Okay. Well, while Logan is thinking, I'll remind you of the construction. The construction is you have circle O given. That's the reflecting circle or the inversion circle, whatever we want to call it. And you have point P. And the idea is to construct P prime, which is the inversion image. And all I gave was this picture. And Logan figured out that you had to draw a circle with center P and radius PO. The circle has to go through the center of the inversion circle. And that circle intersects circle O at 2 points. Pick one of them and call it A. Okay so far?
Yep.
Okay. Now, make another circle with center A that also goes through O, which is the center of the inversion circle. Okay. Where that circle intersects segment OP is the point P prime. Is that all right? Do you see that?
Yeah, I do.
Okay. So that's the construction. And now we have to prove that OP times OP prime equals the square of the radius. And the reason that it has to be the square of the radius is that if that constant, if that product is constant, the constant has to be R squared, because if P were on the circle, which is the reflecting circle, then P prime has to be the same point. And in that case, OP times OP prime is the square of the radius, because each one of them is R. So if it's to be constant, it has to be R squared. So that's the definition of inversion, and now we want to prove that that P prime really is the reflection image in the circle. That is, we want to prove that OP times OP prime equals R squared. And that's not immediately obvious.
Yeah, no.
So Logan is thinking. Logan, any ideas?
Do you have to prove somewhere that OP plus OP prime is equal to 2 OA?
No, and that's not true in general. Because if P is very, very far away from the circle, you know, P can, so that's it's not a plus relationship. It is a times relationship. So here's your hint. So we'll start off. You have to draw some segments. You have to draw some segments, and you have to make triangles. That's one of them.
I guess maybe one.
Yes.
P prime 2 just right now. Wait, is this is the same distance too, isn't it?
No, you not that one, because R is not a special point. R is, and I'm sorry about the confusion. So undo that.
Okay.
And that intersection doesn't enter in. There's a point you haven't used in drawing your segments, and that point is really important because it's the given point. Yeah, it's got to connect somehow with a given point. So draw something from P to somewhere.
Oh, is triangle OPA?
Wait. Which segment do we want to draw, Ryan?
Oh, AP?
Yes. So hold on. Okay. Yes. Now you have, and now Ryan, what were you going to say?
Is triangle APO congruent to AOP prime?
Yeah, not congruent. That's not the word you want.
Or similar.
Similar. Yes, it is. Yes, those triangles are similar. Yes. Now the question is, how do you prove it? So think. You think, and Logan thinks. You are right. Triangle. I'll name it. I'll start with the vertex. Triangle PAO is similar to triangle AOP prime. That's true. So now think about how. So in other words, it turns, right, and it gets smaller. So how do you prove that? Now think first. All right. Any ideas? You don't have to have a complete proof. Just give me some facts about those triangles to start with. Any facts? Any interesting facts? Logan, do you have any facts you can give me?
They share a congruent angle.
They do. Which angle is that?
O.
Yeah, that's right. Angle AOP. Yes, they share an angle. That's really important. So they have one angle in common. What else is true about those triangles that's really interesting?
They're both isosceles?
They're both isosceles. Right. They're both isosceles triangles. So if they're both isosceles, what does that tell you about angles?
They
then they have two congruent angles.
Yes. Yeah. That's right. There you go. Okay. So they are similar. That's right. And once you prove triangles are similar, what can you say about side lengths?
Oh, that they're proportional to each other for each side. Okay.
Yes. So you need to set up a useful proportion involving the lengths that you want.
Yeah. So AP
Mm-hmm.
and AO.
Mm-hmm. That's right.
And then you find
AP
AO.
over AO. That's right.
Yeah.
Can you use the text box,
yeah.
Ryan? And Logan, I mean. And yeah, the text is ABC. It's toward the right there. Yeah. Now if you, yeah, that's right. If you get it and you just, there you go. So, and you can use, let's see. You see where it says symbols? You can get a slash from that when you want it, or a division or something, I think. Can you? I don't know. Maybe not. Anyway, you can just use your slash. You can just use your slash. So go ahead.
AP slash AO is going to equal AO and OP prime.
Right. Good. All right. So there's a proportion. And now what do you think you want to do to that proportion? Unfortunately, I don't know how to make it bigger. Oh, yes, I do. You see where it says small? If you select it, yeah, you can say large. Yeah, there you go. Good. And what do you think you want to do to that proportion?
Solve for OP.
Yeah, or you don't necessarily want to solve for something. You want one product equals another product.
Oh, I see. Okay. That took me a while to get to that. Yeah.
All right, fine.
I don't know how to do.
There's a times there somewhere. There you go. There. Oh yeah, right. AO squared. Very nice.
Equal to OP prime.
Yeah. Now AO squared is what? What is AO?
It's the radius.
Yeah. Bingo. You got it. Good job.
Yeah, I would not have thought about it that way. I don't know.
Yeah, well, it's hard. when I wrote to my colleague Henry, who was working on this stuff with me, and I use a lot of his stuff, and he said I don't see it right away, and he's been teaching for a long time. So yes, it's not easy. But once you draw the pictures. And I'll tell you so. Incidentally, Ryan, are you gone? Yeah, Ryan.
I'm still here.
Okay. Whenever you have to go, just go. Just want to tell you, don't be like that. We used to say when we were teaching geometry, when I taught geometry, we had a little saying. It's like a Swami in India. Just something to remember. When in the land of circles, my son, draw radii. That's something that's right. That's always a useful thing to do. And notice that we drew 3 radii here. That was really the crucial step. 2 radii of circle A and 1 radius of circle P. That was the important thing. And the other radius of circle P we already had. So that was the crucial insight. And then once we did that, Ryan, you saw right away that we had similar triangles, and then we had to prove them similar. And then usually once you prove that, since we want to prove something about sides, we want to make a proportion. And so once you sort of get on that track, then you're on track for the others of the other problems of the same type. Okay. Now, I made. Let me just say one thing before you have to go. I made a test preparation sheet that I'm going to send you guys right after this is over, and I made a test that I will send to your tech lead, which is Steve Orr, right? Do I have that right?
Mr. Year, yeah.
How do you pronounce his name? Ur?
Year, like.
Ur. Okay, I
Yeah.
pronounced it well. Ur. Yeah, so I'm going to send it to Mr. Ur. And so you'll have till the following Friday to complete the test. And one of the problems on the test will be identical to one of these problems. Exactly the same. Okay. Except for one little part. Yeah, one little 2-point part at the end, which will ask you to think about it a little bit. But the rest of it, the eight out of the 10 points will be identical. Okay. Logan, do you have more questions?
No. Yeah. I think I'm good.
Okay. You should. I know you didn't get a chance to do that assignment that you missed, but you should at least, if you look at it and make sure that it makes sense to you at some point. And the other thing I want to say to you that's really important is, was this helpful?
Yeah.
Yes. And so if you have time, I am available. It's not just during class. If your problem is, of course, getting time. I mean, I understand that you've had all these scholarship applications to do and all your other coursework and all that kind of stuff. But if you do get a little time and you have questions and need help during the next month, the last month of the course, I'm here for you. Just let me know and we can meet for as long as you want.
Yeah. Okay. Yeah. Thank you.
All right. You are welcome, sir. All right. I since you don't have any more questions, I think we're done for today. Okay. So just let me know. And Ryan, good luck with the rest of your trip. If you're there, I think you had to leave. All right. All right, Logan. Have a great weekend.
Okay. Bye. You too.
Okay. Bye-bye.
How do I,